In this video, we're going to look at how we calculate our pH, our POH, our H+ concentration, and our OH concentration. Our goals are to explain the relationship between the hydrogen ion concentration and the pH of a solution, and then calculate the pH of a solution. So we saw the pH scale a little bit earlier. Our pH scale is going to go from 1 to 4, so that's something you need to know. And then our H+ concentration then is going to go from 10 to the negative 1 all the way down to 10 to the negative 14. So you can see as we're becoming more basic, the concentration of our H+ gets smaller and smaller. Now we have something called an equilibrium expression for water, and that's our Kw. And our Kw is equal to the concentration of our H+ ion times the concentration of our OH ion. And our Kw is always going to equal 1.0 times 10 to the negative 14th. So whatever combination we have of our H+ and our OH, it has to equal that 1 times 10 to the negative 14th. So now we're going to look at how we go through all of these different calculations. So there are some equations you're going to have to memorize. We're going to start with some of the easier ones first. So the first is converting your pH to your POH. And that equation is pH plus POH equals 14. So if my pH is 10, then my POH is 4. If my POH is 1, then my pH is 13. Okay? So we can go ahead and we can use that equation to move back and forth between our pH and our POH. One note that I want you to jot down is that your pH is going to determine if a substance is an acid or a base. So sometimes you'll be given the POH, and then it's asking you if it's an acid or a base, and you have to find out what the pH is. So that's one application of this equation right here. Now, if you have the pH or the POH, you can actually convert that into your H+ or your OH concentration. And that's just 10 to the negative pH here and 10 to the negative POH here. If you know the concentration of your H+ ions and your OH ions, and you want to figure out what that pH or POH is, then it would be negative log of your H+ or negative log of your OH. And then this is the equation we saw before. So we know that our H+ times our OH is going to equal 1 times 10 to the negative 14th. So this looks like a lot. We're going to be using it a lot. You're going to get a lot of practice. So then that way it just becomes second nature. So let's go ahead and go through a practice problem. It says, what is the pH of a solution with a POH of 5? So if I'm looking at my chart, I'm starting here, right? I know my POH is 5, and I'm going to use this equation. So my pH plus 5 equals 14. I subtract over the 5. 14 minus 5 is 9. So my pH would be 9. Now, in this one, it says, okay, you have a pH of 9, and you're starting down here. What is your H+ concentration going to be? Well, that is 10 to the negative 9th. And for this, because it's a whole number, this math is really easy. If you put in your calculator, you'll get 1 times 10 to the negative 9. I'm okay with either of these answers, but the way you would write that answer is H+ is equal to 1 times 10, negative 9. Now, if it's not a whole number, it's not going to come out very nice, and so you will have to go 10 to the negative value. Now, for this situation, I know the concentration of the OH is 1.0 times 10 to the negative 5th, and it's asking me to find my POH. So in this case, I'm going to use the negative log. So I'm going to do negative log. I'm going to make sure that whole thing's in parentheses, 1 times 10 to the negative 5th. And I will get 2 sig figs. So that is going to be, 2 sig figs. So that's going to be 4.8. And this would be my POH. For this one, I know my H+ concentration is 2.5 times 10 the negative 9th, and I want to find my OH concentration. Now, if you wanted to, you could go all the way around, but I probably would recommend using this equation right here. So we have 1.0 times 10 to the negative 14th equal to, and then our concentration of our H plus, which is 2.5 times 10 to the negative 9th. It's negative there. And then that's going to be multiplied by that OH minus. So I'm going to take the 1.0 times 10 to the negative 14. I'm going to divide it by this 2.5 times 10 to the negative 9th. When you do this calculation, you absolutely have to make sure that this number is completely in parentheses, otherwise you're going to get a wonky number. And the OH concentration is going to come out to be 4.0 times 10 to the negative, 10 to the negative 6th. For this one, we're starting out with 4.0 times 10 to the negative 6, and then we want to find the POH. So we're going to do negative log of the OH. So that's negative log of my 4.0 times 10 to the negative 6, and you should get your POH with 2 sig figs to be, I'm sorry, that's a 5.4. So for this one, we're starting with a pH of 5.4, and we're going to find our pH. So we're going to use pH plus POH equals 14. So that's pH plus 5.4 equals 14. We're going to take the 14 and subtract out that 5.4, and we're going to get our pH to be 8.6. And then finally, one more time through, we've got a pH of 8.6, and we want to get that H plus. We're going to do 10 to the negative 8.6. And if you notice, this time it's not going to come out clean, so we actually do have to put that into the calculator. And when we put that into the calculator with 2 sig figs, it's 2.5 times 10 to the negative 9th. You're going to get a lot of practice with this. If you have any questions, please make sure you're writing them down, and then when we see each other next, make sure you ask.